Hello students, in this video we'll understand the Newton's second law of motion. We all know that there are three laws of motion, three Newton's laws of motion: the first law, the second law, the third law. But the second law of motion is very important. Again, I'm saying it's also relevant to boards entrances, but in our daily life also Newton's second law of motion is very much common and very much more applicable. So in today's world, most of the things, most of the developments or advancements in mechanics that has taken place is mainly due to the understanding of the Newton's second law of motion. Now, the formula of the Newton's second law of motion, that is F is equal to ma, is very common among the students. Even it is written on the boards, on the books. Most of the places it is written F is equal to ma, and the students are very much they have just they remember this formula. But most of the students don't understand what is the meaning of F is equal to ma. F is equal to ma, we all know that force is equal to mass into acceleration. But how do we get force is equal to mass into acceleration? Now this, how do we derive it? That is known as the Newton's second law of motion. Now first we'll go to the definition of the Newton's second law of motion. Now we'll see first the definition. See that according to Newton's second law of motion, acceleration produced on a body by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the body. Now we all know that what is acceleration? Acceleration means change in velocity, either increase in velocity or decrease in velocity per unit time. But how does the change in velocity take place? When some force is applied either in the direction of the velocity or opposite to the direction of velocity. That means some force has to be applied to create acceleration in a body. So we see that suppose let us consider there is a body. Okay, now if there is a body and a force is acting on it, F, and an acceleration produced on that body is A. Now that acceleration produced will be in the same direction as the direction of the force. Suppose the force acting on a body is along the x-axis, that means the acceleration produced in the body will also be along the x-axis. So we see that according to the Newton's second law of motion, acceleration is directly proportional to the force applied and in the same direction. Now you see there is arrow mark above acceleration and force. What does this mean? You all must be knowing two quantities as scalar and vector quantities. Now vector quantities are quantities that have both magnitude and direction, and we all know that acceleration has direction, force has direction, and both have magnitudes too. So acceleration and force both are vector quantities. That's why you see that there is an arrow mark above the acceleration and force. So according to the Newton's second law of motion, acceleration is directly proportional to the force applied, and the acceleration produced in the body is in the same direction. Okay, so suppose if force is doubled, acceleration will also be doubled. Okay, because why? Because acceleration is directly proportional to the force applied or the magnitude of force applied. So suppose force applied on a body is doubled, so acceleration produced in a body will be doubled. Force applied on a body is half, then acceleration produced in that body will be half. Now one more thing is that acceleration produced in a body is inversely proportional to the mass of the body. Now it's common sense. So suppose let us consider there is a body. Okay, now there are two bodies, one body and second body. Now let us consider that the first body is made of iron and second body is made of rubber. Now if we want to produce an acceleration in both the bodies, same amount acceleration, so we need to apply a larger amount of force in case of the larger body, larger amount of force in case of larger body, and small amount of force in case of smaller body. So you see that if a same amount of force is applied on that iron body and that rubber body, acceleration produced on the larger body or the body made of iron will be small, and the acceleration produced on the rubber ball will be large. Why? Because mass of the iron ball is very large, so acceleration produced will be very small. Okay, now an acceleration produced on the rubber body will be very large. Why? Because the mass of the body or the rubber body is very small. So you see that acceleration is inversely proportional to mass. That means if mass is very less, then acceleration produced will be very high, and if mass of the body is very high, acceleration produced will be very less. Now if we combine these two equations, that acceleration is directly proportional to the force, acceleration is inversely proportional to the mass, we get an equation like this: acceleration is directly proportional to force by mass. Now if we remove the sign of proportionality, we get a constant of proportionality k. So now acceleration is equal to k into f by m. Okay, vector sign is still present. Now if we see that for unit magnitudes of all values, let us consider acceleration is 1, mass is 1, and force is 1. We get k is equal to 1. Now k is equal to 1. Now what we'll get? Acceleration is equal to force by mass. Okay. Now if we rearrange this equation, we'll get force is equal to mass into acceleration. Now this is the formula for Newton's second law of motion, that is F is equal to ma. Generally you see written everywhere that F is equal to ma. Vector sign is not written, but actually vector sign is prevalent. Whether it is written or not, vector sign is automatically present. F is equal to ma. Now this mass m is constant. Now this formula is applicable only when the mass of the body is constant. So force is variable, force can be variable, acceleration can be variable, but mass has to be constant. So for a constant mass of m, we have the equation force is equal to mass into acceleration. Now you all must have understood the Newton's second law of motion. Okay, now there is one more way to describe the Newton's second law of motion. We have one more definition. What the definition is that Newton's second law of motion is also defined as force is equal to the rate of change of momentum, or even you can write force is equal to or directly proportional to. Suppose you can write here like this: force is equal to or directly proportional. So you see that we have one more definition, that Newton's second law of motion is also defined as that force is equal to or directly proportional to the rate of change of momentum. Now what is momentum? Momentum, we all know that momentum is it is a quantity that is described by the product of mass and velocity of a body. Suppose there is a body of mass m moving with velocity v, its momentum will be mass into velocity, that is m into v. Okay, so now let us consider, we have to describe the Newton's second law of motion. Let us consider there is a body of mass m moving with velocity u, that is initial velocity u. After a time t, suppose let us consider that a force has been applied on this body. Now let us consider that a force has been applied on this body. Okay, a force has been applied on this body. Now that force applied created a change in the velocity of the body. Now mass is not going to change, that's obvious, mass remains the same, but force creates a change in the velocity of the body. So now final velocity after time t is mass remains same and final velocity v. Now if we take momentum, the initial momentum p naught will be mass into initial velocity, that is m into u. Now after time t, the final momentum will be pt is equal to mass into final velocity, that is m into v. Okay, now change in momentum will be final momentum minus initial momentum, that is m v minus mu. Now m will be common, m into v minus u. Now what we know, we have to find out that the rate of change in momentum. Now what is rate of change of momentum? That is change of momentum per unit time. That means what will be m into v minus u by t. Okay, now according to the definition, force is directly proportional to the mass into velocity, mass into v minus u by t. That means force is directly proportional to the rate of change of momentum. What is rate of change of momentum? M into v minus u by t. So by the definition, F is directly proportional to m into v minus u by t. Now if we remove the constant of proportionality, it will be F is equal to k m v minus u by t. Now we know that v minus u by t is nothing but acceleration acceleration. What is acceleration? Change of velocity per unit time. Now this is v minus u is change of velocity, this is time, so change of velocity per unit time will be acceleration. So this v minus u by t will be a. Okay, so now again we have f is equal to k into m into a. Now as we know from the previous equation that k is equal to 1, we can prove that. Okay, so when k is equal to 1, then f is equal to ma. So you see that we have derived the equation. Okay, we have derived the equation f is equal to ma in two ways. So we have the definition of Newton's second law of motion. You can write this or this. Now in exams also, if this comes, you can write both the definitions and you can derive in both the ways. Both the definitions are correct, both the derivations are correct. Now I think so you all must have understood the Newton's second law of motion. So you can also check out my last video. Last video was on the optics, that means the total internal reflection of light. So that was also a quite interesting video. So I think so you all must have understood this Newton's second law of motion and total internal reflection. So in the coming time I'll be putting up more videos in the future, in the future time. So if you have any doubt, if you want to know about any topic, if you want to learn any topic, you can write in the comment box. I'll try to explain to you. I'll try to bring that topic on the YouTube. Okay, I'll try to make you understand, make a video and upload it on the YouTube so you can understand it well. So I hope you all have understood it properly. And if you like this video, I think so you should like, comment, share and subscribe too. Okay, so that you constantly remain in touch with my videos on physics, so that you get to understand physics in a more lucid and more understanding way. Okay, you get to enjoy physics. So I hope you share it with your friends, family members. So this is the end of the video. I'll see you in the next video. Thank you so much.